Okay, welcome to week number 6, module number 2. So today we are going to continue on the final part of this module. So previously we started talking about precedence, and now today we are going to talk about some conversions. So C++ automatically converts narrow values into wider values. So in terms of narrow values, just keep in mind integer is a narrow value and a double is a wider value. For instance, if I say a is equal to 3, which is a is an integer, and double x y is equal to 7.5, then I say x is equal to a plus y, then C out x. So I will get x as a 10.5 because it is the addition of an integer with a double. So it is 3 plus 7.5 will equal to the value of x, which is 10.5. So this is an integer, this is a double, and the answer is also a double. Okay, the answer is also a double, but this is a little bit tricky. You need to be careful. So integer a is equal to integer a, then we have float b is equal to 3.5, float c is equal to 5, integer d is equal to 2. What is the type of a? A is an integer. So let's do the calculation here. B is equal to 3.5 multiplied by C, which is equal to 5, divided by D. So what is 3.5 multiplied by 5? 3 by 5 is 15 and 5 by 5 is 2.5. So it will be, 2.5 plus 15, it will be 17.5 divided by D, which is 2. So 17 by 2 is 8.5. 0.5 by 2 is 0.25. So we'll have to settle down with 8.75 is our answer. Since a is an integer, our output will be an integer, which is 8. Okay, our output will be an integer, which is 8. Remember, your output, okay, your output is an integer. A is an integer. So you do the calculations. When it comes to displaying the output, we display the output as 8. Another example over here. A is equal to 10.75 and a is a double. Integer b. B is equal to the integer of a. What is the integer of 10.75? It is 10 over here. A is equal to 10, B is equal to 4. All of these are integers. D is only the double. Now let's take a look. D is equal to A over 2. What is A? A, it is 10. What is B? B is 4. 10 over 4 is 2. Okay, 10 over 4, it's actually 2.5, but since it's an integer divided by integer, you are going to get your output as 2. Since D is a double, your answer will be 2.0, not 2.5. Be careful. Integer divided by integer, you get an integer. Then, since D is a double, we convert it to a double by adding 0.0. So C out D, your D will be 2.0. Double A divided by B. When we say double A, it means convert A temporary into a double. So we have a 10.0 divided by B, which is 4. So this will give us a 2.5. C out C. So CU will be a 2.5. Now 2.5 or C is equal to A or B. A divided by B, again it will be a 2.0. And finally double A divided by B, it will give us the output as 2.5 over here. Okay, so we check the answers, you'll get them at 2.5. Then we have the logical operators. So the logical operators over here are questions. These are rational operators. These are question. Is less than, is greater than, is equal to, is not equal to, is less than or equal to, is greater than or equal to. So these questions will have one or two answers, either true or false, either 1 or 0, either yes or no. So if I say x is, this expression means, is x equal to y, is x less than y, is x greater than y, is x not equal to y, is x greater than or equal to y, is x less than or equal to y, and our answer will be either true or false. So we cannot confuse the equal with the equality. Okay, we cannot confuse the equal with the equality. This, if I say 5, a is equal to 5, this means I gave a value of a to 5. If I say a equal 5, this means, is a equal to 5? Okay, so this is a question. This one is a value. It's like assigning a value of a into 5. So for example, if I say x is equal to 20, y is equal to 10, then I ask, is x equal to y? Here, is x not equal to y? Is x greater than y? Is x less than or equal to y? And x is not equal to 0. So these are the operators. Next up is our logical operators, and in the logical operators we use and or. So a simple way to understand them, if I say, if I consider an electrical source with a switch over here and a switch over here, and this is my light, and this is my A, and this is my B, this is called the AND operator. In order for this light to be switched on, both switches should be closed. So if I have my truth table A, B, A and B, so if I have 0, 0, 1, 1, 0, 1, 0, 1, so 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1. Okay, 1 and 1 is 1. In order for this light to be switched on, we need to have both the switches on. Both switches on. This is the AND operator. This is the AND operator. The other operator we have is the OR operator. Same example. I will say, consider this my light source, and then I will give a switch over here. This is my A, this is my B, and this is going to be my light source. Okay, so this is my light source. So in order for this light source to be on, either one of these two should be on, or both of them can be on. So if I do my truth table, this is A, this is B, this is A or B. So 0, 0, 1, 1, 0, 1, 0, 1. So 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, 1 or 1 is 1. Okay, so this is my AND and OR operators. They are called logical operators. So for example, this example over here, it means AND. So I need to have, is x less than or equal to y, and is y not equal to 0. So both of them should be true in order to evaluate this function over here. So these are our logical operators. So the compound operators, again, oh sorry, I forgot this one. This is the not operator. So A, not A is equal to the negative of A or the inverse of A. Just keep in mind, any non-zero number is true. Any non-zero number is true. The only number which is false is the 0. So over here, is A Okay, a is equal to 5. Is 5 less than 2 multiplied by b minus 7? So what is 2 multiplied by b minus 7? 2 multiplied by b is 6. 6 minus 7 is minus 1. Is 5 less than minus 1? So the answer will be false. Now, is c not equal to minus 1? C is equal to 10. The answer is true. Is b, which is 3, greater than c, which is 10? 10 plus 4 multiplied by 7 is 28. 10 plus 4, 28 is 38. Is 3 greater than 28? So this is a false also. Then we come to these expressions over here. Is a less than b? Nope. A is 5, b is 3. Or is b less than c? True. So it will be a false or true. So it will be a true. This one, is a less than b? Nope. So again, it's false, because in the AND gate situation, you don't have to check the next one. If you get one as false, immediately you don't have to check it. The last one, not a minus b. So what is a minus b? A minus b, 5 minus 3 is 2. Not 2. Any non-zero number is true. So not true. And 2 multiplied by a, which is 10. 10 minus 3, which is 7. So it will be not true. So it will be not true and true. Not true is false. False and anything will give you a false. The other thing we want to talk about over here is the function called CMath. And CMath is basically a library which contains these functions: sine, cosine, tan, square root, log, floor, absolute value, arc sine, arc cosine, arc tan, log to the base 10, power, and ceiling. We have already discovered power earlier in the Einstein class in week number 5. So the rest, we can use them when we need them, depending on the mathematical function. So if you are going to use the power, you need to include the hashtag include CMath in your library in order to find the power. So short circuit evaluation, when you have an AND gate, okay, when you have an AND gate, if you evaluate this part as false, no need to check this one. Immediately the function is false. So over here, when I did not true, which is immediately false, I could have gone immediately to the part and said, okay, I could have gone immediately to the part and said that this part is false immediately. Okay, no need to go through the full function. So this is mainly our end of module 2. We are going to have more examples, and these are the basic tools which we are going to use in module 3 and module 4. Module 3, we are going to talk about non-sequential programming. We are going to talk about basically the if statement, the switch statement, the for loop, the while loop, the do loop. Then in week number, in module 4, the final module, we are going to talk about functions and arrays. Thank you for watching. Hope to see you all soon.